Assalamualaikum and hi everyone. This is the topic for properties and circular convolution for ESA 563 digital signal processing. The learning outcomes for this topic is the first one, the list properties of DFT, and the second one is soft circular convolution between two periodic sequences. Slides used in this video are based on the monograph by Dr. Hazli Hashim. In this section, we present the important properties of the DFT in view of the relationships established in previous topics between the DFT and Fourier series, and also Fourier transforms and Z transforms of discrete time signals. We expect the properties of the DFT to resemble the properties of these other transforms and series. However, some important differences exist, one of which is the circular convolution property derived in the following section. A good understanding of these properties is extremely helpful in the application of the DFT to practical problems. The notation used to denote the endpoint DFT pair Hn and Hk is this one. So using the DFT and inverse DFT, we can determine Hn and Hk based on endpoint of signal. So the first one is to determine a finite duration sequence Hn based on the finite duration sequence Hn from n equal to 0 until n minus 1. So using this sequence Hn, we can determine Hk equal to the summation of from n equal to 0 until n minus 1 for signal Hn multiply with exponent negative j 2 pi nk divided by n for k from 0 until n minus 1. And then using the inverse DFT, we can determine a sequence Hn from Hk which equal to 1 over n with the summation from k equal to 0 until n minus 1 for signal Hk multiply with exponent j 2 pi nk divided by n for n from 0 until n minus 1. So we already recall that the DFT and inverse DFT for n points sequence for Hn. So based on these two equations. The second one is periodic extension, where Hn is equal to the summation for m equal to negative infinity until infinity for signal Hn plus m multiply with n, where n is the period of sequence signal.